All right, so I have the right questions now. So I was on the wrong PowerPoint. Sorry about that. All right, somebody is coming in. All right, so you guys have been studying about data this unit. And so you have been looking at types of questions. So when you ask a question that is considered statistics, that means when you ask a question, you want to make sure when people respond to give you an answer, that there's variability in the answer. So for example, I would not be able to ask a yes or no question and say that my statistics show me that most people answer no to this question. That's not a good question. For a statistical question, there needs to be variability. So a lot of different answers when a question is asked, okay? So like I said, don't ask a yes or no question, because if I ask you a yes or no question, there's only one of two things you can say, right? Don't ask questions with one answer or even maybe only two answers. So for example, if I was going to say, let's see, who in this class, I don't know, completes the most work? Well, if we look at the grades, there's probably only one answer, right? You guys, I mean, there wouldn't be multiple answers to that question. So that would not be a good question to ask as well. Be specific. If you want to know how many hours students spend at the park, you would not say, hey, did you go to the park last week? No. You would say, how many hours that should say do, how many hours do you spend at the park? Oh, that's a terrible question. Per week, okay? So whatever it is that you want to know, that is the question that you're going to ask. So be very specific. All right, so keeping those things in mind, which of these is an example of a statistical question? What is the top selling board game? How many board games have you played in the last month? In what aisle are the board games located in the local store? How many board games require a deck of cards to play? Which of those four, A, B, C, or D, is an example of a statistical question?
D.
D. How many board games require a deck of cards to play? Does anyone agree or disagree with D?
I agree.
You agree? I'm going to have to disagree with you guys. I'm going to have to disagree. Does anyone want to tell me why that I would probably disagree, or maybe which is a better statistical question?
B.
B? Yes. So if I asked you, London, how many board games did you play in the past month? If I asked Eduardo, if I asked Jude, if I asked Sean, couldn't I get all kinds of different answers? Some of you would say 0, some of you would say 5, some of you would say 10, probably not, but maybe. But the last one, there's a definite answer, right? If I had 10 board games sitting here and I showed you them all, and then I said, how many of these board games require a deck of cards to play? There would be a definite answer. So that's why D would not be the best answer, because B doesn't have a specific answer, right? Letter C would also have a specific answer. If I went to Walmart and I asked someone, where are the board games? They wouldn't say, well, there's some over there and some over there and some over there. They would tell me what aisle they're found on. So there's only one answer to that as well. And letter A, also, we could prove with facts what the one answer is. So do y'all understand why B is a statistical question?
Yeah.
Good. So you just, you need to be able to identify a statistical question tomorrow on the test. All right, so hopefully you guys recognize both of these types of graphs. What is the top one and what's the bottom graph called?
The top one is called a box plot, while the bottom one is called a histogram.
Exactly. That's exactly right. Very good. So what a box and whisker plot does, or a box plot does, is it divides our data into fourths, right? So the lowest 25% of our data ranges from 20 to 25. The box shows our middle 50%. This is the middle 50% of our data. And then the upper whisker to the height, what is that one? The maximum number is the top 25%. So that's what a box and whisker plot does. It divides your data into groups of 4, okay? So according to this box plot, what is the median?
$33.
33, exactly right. So that line that's in the box always points to the median. What is Q1? What does that mean?
Q1 is the first part of the box plot.
Yeah, it's the left side of the box, isn't it? So it's the lower quartile. So Q1, lower quartile, same thing. So this points to 25. So what would Q2 actually the median is Q2. So I've already found 3 mistakes on this PowerPoint. This should say Q3, which is the upper quartile. What's the upper quartile?
41 to 40, yeah, 41.
39.
Well, it's 39, right, London?
Yeah.
Oh,
Yeah, so 41 would be right here, right, Jude? Yeah, so it's 39, which means if like we found the interquartile range, we would subtract these two numbers. So the interquartile range would be 39 minus 25, which is 14. So the middle 50% of our data ranges with, there's a 14 point or 0.14 numbers of visitors that range in that middle 50% of our data. Finally, what's the lowest number? What's the median? I meant, excuse me, not the median, the minimum. What's our lowest number?
20.
The lowest number is 20.
Good. And our maximum is
45.
40. Well, I think it's 44.
44.
Yeah, it's hard to see unless your screen is real big. It's hard to see. All right, very good. So would I be able to, from my box plot, would I be able to find out what the mean of my data is?
Yes.
Yes?
Actually, no, yes.
How could I find the mean?
You take the numbers at the bottom
Mm-hmm.
and then you add them all up and then you divide how many numbers there are.
Wait, hold on. So we're talking about our box plot, right?
Yep.
So I would take these numbers at the bottom. Is this my data or is this a number line?
Oh, wait, no. You can't find it through the mean.
Right, because I cannot tell on a box plot how many people this box plot represents. So I wouldn't be able to know all of my data. It just gives me, you know, like a percentage of the lowest 25%, so on and so forth. And I don't know how many total people it represents. So I can't find the mean from a box and whisker plot. All right, so now down here, we already talked about this is a histogram. So could I determine the mean from a histogram? What do you guys think? Well, let's answer this question first, the second one. By looking at this histogram, could I tell the total number of students the histogram represents?
Yes.
Yes, because there's 3 students that's seen between 0 and 5 shows. There's 7 students. So I could add 3 plus 7 plus 6 plus 4. And I would know how many students they all represented. So look at the next question. So we can say yes on this one. But can I tell the number of students that watched 11 or less stage shows?
Yes.
Yes, because 7 watched 6 to 11 and 3 watched 0 to 5. So that would be 10 students. So we can answer that question. What about the last one? Can I tell the number of students that watched exactly 18 stage shows?
No.
No. We know how many watched between 18 and 23, but we don't know how many watched 18. So thinking about those questions, now let's go back to the top one. Now, do you think we can find the mean of our data?
Yes.
Well, since I can't tell how many exactly watched 18, that means I couldn't find the sum of my data, right? I know that 3 people watched between, but I don't know how many watched 5. I don't know how many watched 4, how many watched 3 exactly. So I could probably guess the mean. We'd say the mean is between this interval, but we can't find one number to represent the mean because of this answer right here. All righty. Okay, we're moving on unless there's any questions. And now my chat box suddenly popped up again. So if you have questions, you can also put it in the chat. Everybody good? All right, look at number 4. If a graph is skewed like number 4, so we would say this one's skewed to the right, should I use the mean or the median to describe the center of the data?
Mean.
If it's skewed, that means there might be an outlier or two. So if it's skewed, then I am going to use the median. So anytime you have skewed data or an outlier, you're always going to use the median. Okay? So number 4, the answer is median. Because an outlier is going to throw off the mean. It's going to make that the mean either seem higher than most of the data or lower than most of the data. Number 5, how would you describe the shape of this dot plot? Would you say that's skewed or is it symmetric?
It's symmetric.
It's symmetric. So if you are going to, so this is very symmetric, right? It lines up beautifully. It looks the same on both sides. And if I was going to describe the middle part of my data on number 5, would I use the mean or the median?
The mean.
The mean, exactly right. If there are no outliers and also if your graph is not skewed, you're going to use the mean because the mean is going to be the best number to describe the middle part of our data. All right, so we are going to find the mean, the median, and the absolute deviation. It should say mean absolute deviation. So how do I find the mean? What am I going to do first?
Add all of them up.
Okay, so I'm going to add 6 plus 3 is 9. 9 plus 9 is 18. 18 plus 5 is 23. 23 plus 7 is 30. 30 plus 4 is 34. 34 plus 6 is 40. And 40 plus 8 is 48. All right, I added them all up. Now what do I do?
So divide it by how many numbers there are.
1,
8.
2, 3, 4, 5, 6, 7, 8.
Okay. And then
So that's it, right? For the mean, I'm done, right? Yep. So the mean of this data is 6. Now, how do I find the median? What do I do first, guys, to find the median?
the median,
order-
you line them all up in order of the number.
Okay, so we order them from least to greatest.
And then find the middle number.
But there's 2 middle numbers.
Then go to the middle of that number.
Right. Well, since in this case, since they're both sixes,
Oh,
that
yeah.
means the median is 6. Good.
Yeah.
All right, awesome. So now I'm going to erase out, I didn't mean to erase everything, but it's okay. All right, so we know that the mean is 6 and the median is 6, right? Now, who can tell me how to find the mean absolute deviation?
Add it up.
You do exactly for the mean, and then when you get the mean,
Mhm,
you add all of those digits. Like, so the mean is 6. We already did it. So
mhm.
you add 6 to all of these digits.
Well, I'm going to subtract 6, right?
Yeah.
Yeah, good. I want to know how far each of these points is from the data, or excuse me, from the mean. So the difference in 6 and 6 is 0. And we always want to use positive numbers. That's why it says absolute deviation. The difference of 6 and 3 is 3. The difference of 6 and 9 is 3. The difference of 6 and 5 is 1. 7 and 6 is 1. 4 and 6 is 2. The difference between 6 and 6 is 0. And the difference between 8 and 6 is 2. Everybody with me? So now, like you said, London, we're going to add up these numbers and divide by 8. So 0 plus 3 is 3. 3 plus 3 is 6. 6 plus 1 is 7. 7 plus 1 is 8. 8 plus 2 is 10. And 10 plus 2 is 12. Divided by 6, divided by 8, because there's 8 numbers. So 12 divided by 8 would be what? Divided by 2 would be 6/4. 3/2, which is 1.5. So that means, what does the absolute deviation mean? Who can tell me? It means how far on average each of these points is from the mean. So that's a small number. The bigger the mean absolute deviation is, the more varied our data would be, the more spread out they would be, right? So that's a pretty small mean absolute deviation. If you have a really big one, that just means your data is very spread out. There's a lot of spread or a lot of variability in your data. Okay, everybody good? All right, number 7. So this is a box and whisker plot. A class has a total of 32 students. According to the box plot, at least how many students made a score of 29 or higher? That's a good question.
20 to 33.
So how many students scored a 90 or 29 or higher? What's your answer? Who has a good answer for this? Anybody want to take a guess? Well, let me give you a hint. Well, how did we say our box and whisker plots are divided?
Between
What percentages do each section represent?
15%.
25%. So each section is 25%. I'm giving you a hint on how to find the answer. There's 32 students. 25% is the same as 1/4, right?
4/4 of 3/4 of 32.
Well,
32
Well,
what'd you say, London?
32 divided by 4.
Exactly, because 29 or higher is this part, right? And that's 25% of my data. 25% is the same as 1/4. So if there's 32 kids in the class and 1/4 of them scored between 29 and 33, that means 8 students scored at least a 29 or higher. Okay? Y'all good with that one?
Yep.
Yeah.
All right, so what about number 8 asks about the same box and whisker plot. And the question is, what is the interquartile range? How do I find interquartile range?
You just
It's the box in the box plot.
It's
Yeah.
the box, exactly right. So the upper quartile is 29. The lower quartile is what, 21? So the interquartile range is going to be 29 minus 21, which is 8. So the next question is, what does this number actually represent? What does the interquartile range represents?
50%.
Right. It shows the range of the middle 50% of your data, right? It shows how spread out the middle 50% of your data is. So that means the middle 50% of this student or this class of 32 students made between a 21 and a 29. Okay. And then we already answered this question earlier. What information can we not find on a box and whisker plot?
the mean.
We cannot find the mean because most of the time we don't have a sentence like this. This one tells us that this box and whisker plot represents 32 people, but most of the time we don't have that data, which means we won't be able to figure out how many people is represented on the box and whisker plot, or how many 21s are represented, how many 29. We know what those numbers are, but we don't know how many of them are actually part of our data. All right. Oh, wow, that's it. What'd you guys think?
Okay.
Not too bad?
Yeah.
Okay.
Yeah.
All right, I'm gonna stop the video.